I think this is session number 4. This particular course is based on just preparing a workplace tech application, inputs and outputs for the BACnet world. One of the notes I just wanted to add with this is, like I said, I see a lot of guys in the field, and you have to do this. Add points, subtract points, add a little programming, and it's easy to do. Everybody knows how to do it, but there's just a few technicalities that should be considered when doing this. Good habits to get into, especially the way the technology is going these ways, and I'll point them out as we go along. We're going to start with some simple I/O first. So we're going to go over to our stencils that have our I/O control. These, whoever's been around for a while is very familiar with them, analog inputs. We're going to start with the beginning there, and I'm going to simply just drag in an analog input. Now, in the BACnet world, the nice thing about it, and especially from the guys who, like myself, worked on LAN for a lot of years, a lot of people, what I am seeing is they're doing their BACnet controllers as if they were still working on LAN. This isn't LAN anymore. BACnet really does have some much more added features, better features. There's a lot of things we can skip in the BACnet world, as opposed to when we used to do things in LAN. Let's take a simple analog input here, for example, and one of the most common things we're going to configure this for is a thermistor. So what we're going to do is we're going to pretend that this is simply a space temperature. Very importantly in BACnet, our analog input object itself, as we look at it, just a plain old AI sitting there, that is a BACnet object. This object can be learned by a UNC or an ENC, or, as I said, as technology goes, eventually someday it'll be structureware. So as we learn this object, one of the things I see some of the guys doing is they pull an object, and like in the LAN world, it really wasn't important to give it a name. Some people like to give it a name, some people don't like to give it a name, some people are in a hurry, some people aren't. But in the BACnet world, the names are very, very important because we learn this object up in a UNC. So it's important to identify it as it is. Or else you find yourself trying to set up a simple graphic screen and you're having to pull out your drawings just to figure out what AI1 is. And back in the days, we used to label a lot of jobs. AI1, AI2 as our inputs, and I'd like to steer people away from that because this is the base, this is the grounds. Workplace tech really is the start of, if you can be a little more accurate in labeling your points in workplace tech, it makes graphics and learning devices and UNC work 20 times easier. So the more you can do at workplace tech level, the more you're going to save down the road when you're working on your graphics. So the first thing I'd like to do is give this, and BACnet's pretty forgiving too with spaces, underscores. We like to use for a long time for labeling. I think when Rob Roddenhouse started working, he mentioned the word camel hump typing, and which is we've been doing it for years, but I never heard it called camel hump. Or what is it? Camel case. Okay, it's camel case typing. And you probably all know what that is just by saying it. So I'm going to right click my analog input. I'm going to go to customize. And I'm going to, instead of AI, the object name, I'm going to give it a plain name. I'm going to call it ROM capital TEMP. That's one way. If you can shorten it up, I've seen RM capital T. You can do a space in there, room temp, however you want to do it. As long as it is labeled, if you even want to put a room number to it, depending on the system, if it's typical of many, I don't typically put a room number in it, because then you can't copy paste 20 programs over. You got to go in and because in my world there's always you're always under the gun for how long does it take to program a job, and we're always trying to find ways to keep hours at a minimum. It's a simple room temp, and again, you can go and you can take a physical tag UI1 from the left as available, and you can link it up, and you'd think you're done, but there's still a little bit more to go in a simple analog input. What I'm going to do is I'm going to double click on my analog input, so I go right into properties, or you can right click and go to properties, and you're going to see the different variables. As we all know, I'm not going to get into input sensor types. That goes back into microzone days. That's probably another class. But we got thermistor because this is a space sensor. We don't need to adjust the low val, the low scale, and all that kind of stuff. However, on the bottom we have this COV increment, and this is one that everybody skips. COV is pretty important in the BACnet world for our overall communications performance. What happens is when this object gets duplicated up in a UNC, and we call that a shadow object, what COV stands for is change of value increment. And what we're telling this object to do is not write to your shadow object unless you've exceeded the value we put in for a COV. So, for example, space temperatures is not a value that changes very often by very large amounts of numbers. So what I like to put in for a COV for space temps is a 0.2. I like to put in a value of 0.2 for space temperature sensors. What this means is this space temp will not write back and forth to the UNC until it actually gone beyond 0.2 degrees. So if the temperature was sitting at an even 70, and then the temperature maybe moved up to a 70.1, it's still going to ignore that. It's not going to write that value yet. Once we get to 70.2, then it's going to update it into our UNC, and you'll see your graphic screen change. That works very well for space temperatures. There are things that need to be done in the UNC as well to make COV work, but this is the starting point. If you can set it down in this level, you just save yourself a boatload of time up in the UNC if you're really taking close consideration and making sure everything's all set to use COV.
Billy,
Yes?
how often does it update without a COV value in there?
That's a good question. Probably... Yeah, it's like every heartbeat. If this thing has a heartbeat in there somewhere, it's going to be every heartbeat. And because of trending, because of the way we do our jobs, we really exceed the amount of the BACnet networks in our world. Not really the number of devices, but how many polled points we have. And we really go well. I think if you call Schneider, they'll say we want a maximum of 250 polled always BACnet objects. And engineering practices, we double it. We go to 500, and we even go beyond that. We'll see some 700, 800, 900. And so what happens if COV is not being used, you can have a pretty bogged down BACnet network. So that's why it's very important. And it's, if you start here at the workplace tech level, you just, some of the guys, and I notice check test start guys a lot because they're really concerned about getting their controller going, getting that piece of equipment going, and then they move on. They really don't get involved in all the graphic development. And so that's why I kind of stress this point to do it at the workplace tech level. As our front end family gets into, like in a G3 world, it's nice because every parameter in this object gets uploaded to it, right from engineering units and everything, and you don't have to set engineering units up in a UNC at all or in a server. If you make it a degrees Fahrenheit down in the controller level, it's going to naturally be degrees Fahrenheit by the time it gets to your graphic screen for viewing, and you'll never have to enter that up in the graphic levels if you do it all in the down here in the workplace tech level, which makes it real easy. R2 is a little bit different story because of the way we do it. We kind of do it twice. If the point is going to get linked directly to graphic from shadow object like we do with set points, they will make their way all the way to the top, but I am just going to preach that best practices. This is the way I program it. So if it's coming out of my department, I would expect that all this stuff is entered. The other thing, when we right click on our analog input, you're going to see when we exit out of properties there and we're back at our main screen, and if I right click my analog input, you'll see units is grayed out. The reason units is grayed out because the input is configured as a thermistor, and thermistor can be nothing else but a temperature. So our value will automatically come back as degrees Fahrenheit. Let's change our object name to like static pressure. So now we got a new object, and we know static pressures are transmitters and not really sensors. So I'm going to go back into my properties of that analog input. Simply, I'm going to configure this guy for volts, number 5 volts. My input low value is going to be 0. My scaled low value is 0. My input high is going to be 5 volts because we always use 0 to 5 volt signals. And our inputs cannot read anything higher than above 5 volts. Scaled high value, we'll pretend it's a duct static pressure transmitter, 2/3 down the duct. So his scaling is going to be 0 to 5 inches is a good number to use. COV on something like that, again, you have to, there's going to be no set standard on what COV value you use. When I think of, you just got to think of the transmitter itself, a static pressure transmitter, controlling a fan. We're usually pretty interested in the tenths because a lot of times you'll see those set points set for 1.5 inches, 1.2 inches, 1.3 for set points. So, we may keep our 0.2, or you can even go down, if you're a little more worried about it, you can even go down to a 0.1 COV increment for a static pressure transmitter. It's all up to you, as long as there's one in there. I'm good with that. Filter constant on transmitters, I always like to max them out to a 0.01 if we want to go into the filter constants. Open up if you want to learn a little bit about the filter constant, just open up your workplace tech manual. There's a whole, it's common for every input, and you'll see the filter just kind of smoothens out. And transmitters are known to be pretty bouncy, so I always like to slow them down. Now you'll notice when I click OK, and we're back to our main drawing here, when I right click on my input, you're going to see units is now available for us to select. So that's exactly what we're going to do is when we right click our analog input object called static pressure, I'm going to go to units. And what you have is engineering units for static pressure. And you're going to see on the left a lot of categories. On the right, by default, you're going to have the common ones used, and 9 times out of 10, the common one is there for us. Inches of water should be in there. Yes, it is. And I'm going to hit apply. And you're not going to see it in the object, but we now have this object. We have a COV set in this object, and we also have its engineering unit set. Which very nicely, when I learn these objects up in the shadow object, all that information is going to get uploaded which is going to be very, very helpful, and it's a big time saver. So those are the important things that I wanted to preach a little bit, because like I said, almost anybody can create and add an input or an output if they need to, but nobody really thoroughly completes it. We're going to grab a binary input now real quick. And just the one thing, if you want to label it and make it all nice, you can go ahead. But the important thing with the binary input, we're going to double click it and we're going to go into his properties. We're going to notice he does have a COV increment as well. Typically what I do for the binary points, because when you think about it, when you put a monitoring tag on this, you're going to either have a value of 0 or you're going to have a value of 100. To me, excuse me, simply a COV increment of 1 will cover this, and it will never read right until it, actually completely changes a state from an on to an off or an off to an on. Excuse me. And I'm going to click OK there. That's really all you need to do in the properties section. The other thing with binaries you can also do, which is very helpful at this level, if you are aware of it. I understand sometimes, and I'll go off the path here, you get some engineering drawings, and you'll see that maybe they have some kind of some type of sensor that's giving us an alarm contact from a third-party device, and the engineer just simply doesn't know what its normal state is. Does on equal alarm or does on equal normal? And you just don't know that up front. And, unfortunately, it is a guessing game. Sometimes I leave those ones alone, and I wait until the system is actually all started up and running. And if everything's running normal, and I see what its value is, and that's when I'll go in and I'll actually change it up in the graphic level to say, okay, this value is on and everything's all normal and running just fine. I think I'll make on normal and off will be alarm in that case. But that's only like 1 time out of 10 that happens. But right-clicking on this object, you'll come up with state text. State text is just like putting engineering units on a binary object. And you do find the most common ones in here: closed, open, open, closed, on, off, on, flow, no flow. Binaries are, one thing we do keep consistent is like fan start stops will always label start for on, stop for off. So this fan start stop is if you got a BO for fan start stop or pump start stop, I'll always go down and I'll select, and they have it in here, start and stop. And then fan statuses, which are most commonly that come back, I keep them simple and I leave them at the default on and off. So a fan command with proofing, if the fan's command is start, you're waiting for fan status to be on, and then that's typically how we do those. If it comes to something like a variable speed drive, I'll use more of an output, label it as an enable, disable, or if it comes to a boiler, enable, disable. That's the only twist I'll have on pump. So if we're enabling a drive, we're really, I like to label it just as we're doing it. We're enabling the drive, and the drive is really, with all the safeties tied in and everything like that, is going to start the pump. Or sometimes I do simply use start stop for a drive as well too. I guess it really depends on the mood I'm in that day. But either way, it's very it's very consistent, because some people that do go ahead and do that, which is really, start labeling things, they'll use some other things like the flow and the no flow, which is good. I mean, that's fine, it works. But if you want to, I'm telling you what we do out of our department. If you want to try to keep some consistency going, then keep jobs similar from job to job and everything. I'm just letting you know how I label them. The other thing, sometimes you do get into some tricky ones where you don't have the standard. You just don't have the standard object here. Someone give me an example of something that may be a little bit off the beaten path. That's not on this list of the standard ones. You got a button on the bottom left that says other text. You can actually click that and you can put in your own customized binaries if you need it. You know, maybe we're working with a, oh boy. Sorry, Mr. Gunnarsson. Okay, maybe we're working with a sensor that's telling us if there's, you know, a snow melt system and there's either snow on the ground or there's no snow. And maybe that's the way the customer wants to read it. So I can just type in snow, and for inactive I can put in no snow. No snow. Do that again. Okay. And there we go. And that would get, actually that would get learned up into the that would get learned up into our shadow object, just like that. And again, you will not have to worry about setting that up again all the way up, or at least if you're done, if the startup guy is all done, he's not going to have to go all the way down or pull out drawings or anything, even if you got to manually put them in graphics, because we're linking it to an AI object in the server that's not learning the engineering units. At least you can look at the object up in the UNC level and see what his engineering units are. And, you know, you can be all good with that. I believe you can also put in a description, too, if you really wanted to, in the properties description. And you can see what that description is up in the BACnet shadow object. So that's a binary input. The same thing, I guess I'll say, when I look at analog outputs, are going to be just like analog inputs. Nice thing about analog outputs is you'll never have to set engineering units on them. They will always default as %. Unless you're doing something tricky, there really is no reason for setting something other than % on them. But they do have COV increments as well. Typically, when I do valves and dampers and van speeds and pumps and things like that, typically I'll use a COV of 1. We really don't need to see a fan speed at, you know, 20.2, 20.3, 20.4. You can even, if it's a bigger, busier job even, you can even go a little higher on those if you want. You can go 2 or 3. I have some jobs that I've gone that high just because I know there's a lot of pulled objects going on. So I'll even do like a pump speed or something. I'll do a COV of 2 or 3. You know, so you will not see that change until, you know, if the pump is sitting at 20%, you won't see him actually change till he hits 23%. And in a lot of cases, that's okay. Some other cases, it may not be okay. You know, it's just all, there's nothing engraved in stone. It's just like, just as long as you use it is, you know, it's really going to make a big difference. The other thing is the binary outputs do not have COV, so you don't have to worry about those. The other objects we got, floating actuator is a pretty common object. Floating actuator will also have a COV in there. Those floating actuators are also a BACnet object, so we use a COV. Again, it's just treated like a valve or a damper. I'll use a 1 or a 2 or a 3, especially if it's like a piece of fin or something, you know. I even may go as, you know, as high as 5 or something if it's fin. fin is really, maybe if it's a critical air handler, you maybe just want a COV of 1, but if you're talking about fin or a VAV reheat coil or something, you may go as high as 5. The other things that's not on here, if you happen to be doing a VAV controller, the VAV controller, the actuator object and the transducer object also has COVs put in there as well for when you're reading your CFMs. A lot of times those are a big one too, because the CFMs on a VAV controller can be pretty bouncy. Sometimes I'll put in, depending on it, I'll put in usually a minimum of 5 CFM for a COV on a VAV box. Moving down to the next, we have some, I'm going to open up the BACnet stencils BACnet object, where we now have our BACnet stencils. Let me just bring up one other point now that we're moving on with our BACnet stencils. I've seen a couple guys still doing this in the field, and this is what I meant about this is BACnet, this is not LAN anymore. But that our analog input object we've been playing with, I still see guys grabbing in your BACnet stencils an analog monitor, and they'll pull that out, and they'll actually link that to the output of the analog input object, just like the LAN world and Snivit. It's not necessary to do that. Now we actually have double BACnet objects for that object, so there's really no reason, and I'll explain the only reason why you may do that, but it'll be properly labeled. And what we will start with an analog monitor. So if you want, pull out the analog monitor value, because we do use them quite frequently. And similar to the inputs, if you just double click and you go into his properties, again, it's another value. It's going to be another COV increment. So, what you're going to find is the setup in Workplace Tech is going to be more of a precision type setup as you're doing your Workplace Tech programming. But again, like I said, you're saving a lot of time up in the graphics level, especially when you're in the projects department, and you're just pumping out 80 gazillion graphic screens every other week. COV, again, whatever it is, it could be a type of space temp. Maybe you're averaging 3 space temperatures, and now you want that average space temp to come out to graphics. Is a great time to use that. Maybe you got a hot water reset, calculating a hot water supply temperature, and you want to show graphically what the hot water supply temperature is. That's the time you're going to use that. I'll put in a COV of 1. And typically also I see a lot of guys don't take the time to label these correctly either. We want to make sure we label them. We'll right click. We'll customize this object, and I'll give it a HWS SPT for hot water supply set point. And there we go. These guys definitely need units. He does not know he's temperature. He does not know he's hooked up to a thermistor or anything like that. So you right click, you'll see that units is highlighted. And don't forget to add your units. And this one's going to be degrees Fahrenheit. Maybe what? If it's a calculated set point coming off of a reset, yes, we would use it for a set point. Where we also use these objects is especially on jobs. Remember the class we had where how to set up remote local set point control? we actually needed one of these BACnet monitor tags to tell us what the actual active set point was. And, that's the same place where we would use one of these monitor tags. The only other thing I do is BACnet has this thing called peer-to-peer. And you are allowed, and it's, what we're finding out, it's exclusively through just our own controllers. You can do peer-to-peer type communication. So if I need to share this to another controller, and I'm looking for something more speedier than updating and sending this up to a UNC and then back down to another controller, where we know that you're going to come into a bit of a timing issue. They have this thing called peer-to-peer, and simply what I'll do and what you'll see, and I'll clearly label that in the object itself. If this BACnet object is definitely going to be used for peer-to-peer, you'll always see, and I'm going to go back into right-click this object, I'm going to go back into Customize, and no matter what that object name is, I'll always add an underscore and put in P2P. And to even clearly identify it even more, sometimes I'll even throw a little note underneath it saying link to, controller number, blah, 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 point number, blah, blah, blah. We'll get into, maybe I'll have another class down the road, we'll get into the nitty-gritty of the Workplace Tech Commissioning tool. That's how we access Link Builder. I have seen Link Builder, these links work nicely. Very fast, very quick, just like the old LAN. If you were to do a direct bind from one controller snippet to another, it's nice and fast and speedy. The problem is they're kind of invisible unless you go into the link builder and dig for them. So you really don't even know they exist. Is what I really don't like about the peer-to-peers. But what I do, and if the software does come from me and it did require a peer-to-peer type bind or a link, you'll see an underscore P2P is the way I label them. What else do we got here? Binary monitors. If we pull a binary monitor again, they do not have, like the BOs, they don't have no COV. What you're going to have, again, is you're going to want to give it a nice name. And you're going to you got the state text window. And make sure you label your state text window. In the G3 world, it's really nice because no matter how you set this up, when you learn these objects up in G3, those engineering units and the object name gets imported into the object. It gets imported into if you create a log for it, the engineering units transfers right over to the log. If you throw it on the graphic screen, display purposes, the engineering units are right there. So in the R2 world, we're used to having to set that up. If you want engineering units in your log, you usually manually set that up in your log as you create it, which is silly, but that's the way it was. And I'm trying to preach and teach and learn to set them up here because G3, if you set it here again, you don't have to set it anyplace else. And I can almost bet the farm that when StructureWare comes out, it's going to be the same thing. It's going to be just a more advanced G3 is what it's going to be, and so doing things down at workplace tech level are going to be less confusing. Other points, I mean, that almost covers just about everything I wanted to talk about. What we'll do is I'll pull in a couple more of these BACnet objects. Let's pull in an analog set point and an analog set point priority. And is there anybody that can tell me when I would use one and when I would use the other? Maybe why and stuff like that. What? Yes, it does. The other thing you did say was the right-click functionality. Back in the LAN days, we would have to take up in Niagara R2, we would have to take a standard analog output object, and we would link that to a snippet and send a set point down to a controller. We can do the same thing in the BACnet world. We can do it with both analog set point priority or an analog set point. We can link an AO to it. The problem with that is, and what I mentioned earlier in the class, and the most important thing that I think about when building our applications is the amount of pulled always objects we have. If we link an AO to one of these objects, we now have it has no choice. It has to be in a pull always container for us to pass down the space set point. What's nice is the analog set point priority objects have the same functions as an AO object as far as having right-click capabilities. So what that means is we can link that directly to a graphic screen, and that's the way the pull-on-demand objects works. If that object is linked to a graphic and you view it, that's when the BACnet object actually pulls, and it's the only time it pulls. So that's perfect for doing things like space set points and other manually selected set points. That's when the analog set point priority gets used the most. If you know you're going to go directly to a graphic screen, and you can change that right-click functionality to say whatever you want. Usually by default we do set because it's the easiest to program. It's quick and it's easy to edit the visual tab, and that's the main reason. And he can sit in a pull-on-demand container, and now we got less traffic, which is nice. The other thing about them, though, too, is if you start using them as a regular polling type input, you can still use them. And I started out my BACnet programming this way, where I would use them I would link outside air sensors to them if I was passing down an outside air sensor, or just about anything that needed to get sent down to a controller. And what I'm finding out is that these input priorities are a little hoggish in the communications. If you need to pass down anything that needs to be automatic, maybe you're sharing a space sensor from another controller, maybe you're passing down the outside air sensor, I recommend using the analog set points. They don't have a priority array for writing, they just have one straight input, and what you link to it passes down to the controller. And it's less resources, it's less memory hoggish. We actually did have a job where I was writing just about all points to the priority array of these analog set point priorities, and found out that it was totally bogging down the whole BACnet network, and that was a pretty bad thing to do. More precisely, what I was doing was the AO, the analog output objects, they work on the same way with the priority array. And I had a bunch of fin valves, and the customer didn't like seeing that fin valves were opening in the summertime when there's no hot water going. So the control logic really wasn't locking the valves out, and I needed a quick way to lock the valves out. So I said, okay, when the boilers aren't running, I'll just link to the priority array of the AO and kind of override them closed. And I found out in the summertime we were rebooting UNCs about 3 times a day because the communications were all bogged down. We got into a call with Schneider about it and everything, and kind of found out that I had to remove all of those. So whenever you're writing directly something live that's always updating in the priority array, you're kind of hogging up your BACnet communications a bit. The other particular inputs we're going to talk about here, you're going to see an analog COV client, and you're going to see a binary COV client. These are special purpose, are only used to receive inputs in the peer-to-peer linking that we talked about with Link Builder. You can create these objects. You cannot use them for anything else but peer-to-peer. You'll find if you were to learn these objects up in a UNC, you really can't write to them. You'll find that you can link to them, but your linking to them will not have any effect. So you stay clear of these objects unless you're really doing, you're going to do a peer-to-peer. And if you're doing peer-to-peer, you've got no choice. You have to have one of these objects in the receiving controller. The output peer-to-peer doesn't matter. Like I said, you can use a plain old analog monitor or a binary monitor to send it out. But you really, really need one of these binary COV clients to set that up on the receiving controller for peer-to-peer. Or else when you go to your link builder, if you don't have these, your controller will not show up as a legitimate receiving controller to even do peer-to-peer. So those guys are strictly for peer-to-peer. They have the same properties. You don't have to worry too much about their units and everything because you're not going to be putting them up on a graphic. But by force of habit, for me it's force of habit to label every point in a workplace tech application. What else do we got here? Do you guys see anything in here that you want me to brush up upon that I may have missed over? Anything at all? It's all pretty, it's pretty simple, but it's, like I said, a lot of guys aren't, doing it this way. They know it's there, but maybe they're just, not sure the effects it really has, how helpful it is to use those COVs or how helpful it is to, label everything. And this class was designed to, because I know everybody out there in the field are adding points. One way or another, they have to add a point. And if you really want to follow through and do it right, like I said, it helps you as the guy down in the controller level, but, globally and to help everybody else out, it's nice to start at the workplace tech level, get everything all labeled nice and pretty down there, and your graphic work is going to be just so much easier when you do that. Easy to follow, easy to read, easy to set up. And the BACnet I felt was pretty important. The COV is a big thing for the overall effect of your BACnet networks. One thing you do have to do, every BACnet object now up in the UNC, the COV does not work by default. Every BACnet object you'll see up in the UNC will have in the Properties tab, it'll have a UCOV, and it'll be set to false. And then you'll have a COV increment. And yes, you can set a COV increment up in the UNCs. However, it's a lot easier to do them down in Workplace Tech. There is a servlet. And maybe someday I'll have a little class on servlets, but there's a servlet called Admin Tool that you can add to your stations. And with that, simply what I do when I'm doing an entire job, I don't worry about individually going into all those BACnet objects and manually turning them on and setting a COV. I use this admin tool, and in one command, I can take every BACnet object and turn use COV to true. And poof, I'm 100% set up on the entire job of COV to work. Before I knew about the admin tool, every BACnet object I was creating, I was manually going into it, and really just every BACnet object got individual attention up in the UNC, and that's how much work it took. But now by making your workplace tech applications a little better, I can really avoid a lot of that extra work. With that being said, if there are no further questions, I think we're pretty good as far as this class went. nice, quick, and easy, and I hope it was informal, informational, or however you want to call it. Informative. Y'all good, Mike?
Very good, Bill. Appreciate it.
Okay, no problem. Yep, have a good one.